In this video, we're going to continue our study of Algebra 1 in the Classical Liberal Arts Academy. And what we're going to work on is the first set of exercises in article number 52. The first set of exercises. So we'll do exercises 1 through 13 in this first video, and then I'll make a second video for the rest of the exercises that come under article 52 in our textbook. Now, it's worth noting that I'm a classicist. I'm not a modern mathematician or a math teacher. But the math textbooks, the modern math textbooks in our curriculum are so simple to study that you don't need a math teacher to master the arts of arithmetic, algebra, even calculus. So we're going to work through these exercises together. It's all very simple, and we're going to do a couple of things for these first 13 exercises. First of all, we're going to practice reading algebraic expressions. So the first step of our exercise is going to be to simply read the expression, to prove that we can look at an expression in algebra, understand what all the symbols and signs mean, and read it in regular language. Okay, so first we're going to read the expression. Secondly, I wrote up here, we're going to analyze the expression. And all I mean by analyze the expression is that we're going to look at the expression and see what can be said about it based on what we've studied in the definitions in articles 1 through 52. So we're going to analyze each expression. And then the third step we're going to take is we're going to find the numerical value of each expression. In the textbook, we're given numerical values for each of the letters that are used in these exercises. Once we've read the expression and analyzed the expression, we're then going to find the numerical value of the expression by plugging in these numbers for the letters given to us in the exercises. Okay, so let's go ahead and get started with number 1 here. Step 1 is to read the expression C plus D minus B. A quantity C plus a quantity D minus a quantity B. That's the reading of the expression. Now, as to analyze the expression, the first thing we want to know is how many terms are there? How many terms are in this expression? And we learned that a term was a quantity separated by the signs plus or minus. So when we look at this expression, we see the signs plus and minus, and therefore we have 1, 2, 3 terms in this expression. There are 3 terms in this expression. We also know that an algebraic expression that consists of 3 terms is called a trinomial. So this is an example of a trinomial expression. All right, 3 terms. C plus D minus B. Now, if we plug in these values that were given in our textbook, we see that the letter C is equal to 5. So we can write 5 plus the quantity D, and D we're told is equal to 10, minus the quantity B, which is equal to 3. 5 plus 10 makes 15, minus 3 equals 12. So the numerical value of the expression C plus D minus B, given these values, the numerical value is 12. Okay? That's all you need to do for each of these exercises. It's not difficult at all. Number 2, our second expression reads 4 times the quantity A minus the quantity X. 4 times A minus X. That's the reading of the expression. When we look at this, we see that there are two terms. The sign minus separates these quantities and gives us an expression with two terms. 4a, or 4 times a, is one term, and x is a second term. Since there are two terms in this expression is a binomial. There are two terms. One other thing we learned in the lesson is that any binomial that has a negative number as the second quantity in the expression is called a residual quantity. So this is an example of a binomial that is a residual quantity. Okay? Now, to solve or find the numerical value of this expression, we're simply going to plug in our values. 4 times a would be the same thing as 4 times 4. 4 times 4, and I'll put this in parentheses because this is one term. 4 times 4 minus the value of x, which is 2. 4 times 4 makes 16, and 16 minus 2 makes 14. So the numerical value of the expression 4 times a minus x is 14. That's number 2. In our third expression, in number 3, we have negative 3 times a times x. Negative 3 times a times x. We could also say negative 3ax, and that means multiplication. Okay, negative 3 times a times x, or simply negative 3ax. Now, if we were to look at this expression, we see that there is only one term, just one term. It's a monomial. There's only one term. Now let's go ahead and find the numerical value of this expression. Negative 3 times a is equal to 4. Negative 3 times 4 times x, which is equal to 2. Negative 3 times 4 gives us a product of negative 12. And negative 12 times 2 gives us a product of negative 24. So given these values for our literal factors, the numerical value of the expression negative 3 times a times x is negative 24. All right, number 4. We have the expression 6 times a squared times x. 6 times a squared times x. How many terms do we have in this expression? A term is a quantity separated by the sign plus or minus. There are no plus or minus signs in this expression, so we have only one term. This is another monomial. Okay? So now let's find the numerical value of this expression. We have 6 times a squared. So we have 6 times a is equal to 4. 4 times 4 times the quantity x, which is equal to 2. 6 times 4 times 4 times 2. 6 times 4 is 24. 24 times 4 is 96. And 96 times 2 equals 192. 192. Now, that multiplication may be a little bit difficult for you, and if you need to use a calculator to find that product, or you simply need to scratch it out on paper, and so that's fine. That's really not our concern. That's just arithmetic, all right? But writing out this expression, 6 times a squared times x, we have 6 times 4 times 4 times 2. And that gives us a product of 192. So the numerical value of 6a squared times x is 192. Number 4. On to number 5. Looking at number 5, things begin to get a little more complicated. But remember, when we look at an algebraic expression, we want to learn to read the expression and then analyze that expression based on the definitions that we've learned in Articles 1 through 52. So what we have here is a times y, the product of a times y divided by the quantity b. A times y divided by b. We could say that more simply as ay over b. Ay over b plus cd over x, or c times d divided by x. A times y divided by b plus c times d divided by x. That's the reading of the expression. Now, if we look at this expression, we see that there's a plus sign, and therefore we have two terms. A times y divided by b is one term, and c times d divided by x is a second term. So this is a binomial. Even though it looks a little complicated, because we have this written as fractions, which signifies division, even though it looks a little more complicated, it's simply two terms separated by a plus sign. It's a binomial, okay? So now let's go ahead and find the numerical value of this expression. We have a times y. So that would be 4 times 6. 4 times 6 makes 24. So I'll write 24 divided by b, which is 3, plus c times d, 5 times 10, which makes 50, divided by x, which makes 2. 24 divided by 3 is equal to 8, plus 50 divided by 2 is 25. 8 plus 25 makes 33. So the numerical value, given these values of the literal factors, the numerical value of ay over b plus cd over x is 33. That's the answer to number 5. On to number 6. If we take a quick look at number 6 and just skim over the expression, we can see that we have a plus sign and a minus sign. So we have three terms, term 1, term 2, and term 3. So this is a trinomial, 3 terms. We have 3 times a squared, that's term 1, plus 2 times c times x, that's term 2, minus b to the 3rd power, or b cubed. That's term number 3. So we've read the expression. We know that it's a trinomial. Okay, now let's find the numerical value. 3 times a squared. A is 4. Therefore, 3 times a squared. 4 squared will be 16. 3 times 16 makes 48. Plus 2 times c times x. C is 5 and x is 2. 2 times 5 is 10. Times 2 is 20. So 2cx, or 2 times c times x, is equal to 20. Minus b to the third. b is equal to 3. 3 to the third power is equal to 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So we have 48 plus 20 minus 27. 48 plus 20 makes 68. And 68 minus 27 makes 41. Therefore, the numerical value of 3a squared plus 2cx minus b to the third power is 41. That's our answer to number 6. All right, on to number 7. In number 7, for the first time in an exercise, we're given parentheses. And if you remember in our definitions, we learned that parentheses are used to show that the quantities contained within the parentheses are to be treated as a single term. All right? So we'll solve, or we'll find the numerical value of this expression inside the parentheses first. So let's do that. We have a times the sum of a plus b. A times the sum of a plus b. A is equal to 4 and b is equal to 3. So a plus b is equal to 7. And we'll keep that in parentheses just to remember where it came from. We have a is equal to 4. So 4 times 7 is equal to 28. So the numerical value of a times the sum of a plus b is 28. That's number 7. Number 8. Now, when you look at these exercises, what they're testing is what I warned you about when we were looking at the definitions. I warned you that if you didn't learn the definition of a term, you would get yourself into trouble when we study and need to use the order of operations. And here's a good example where not understanding what a term is will get you in trouble. If there's a student who tries to solve this exercise, number 8, and find the numerical value, and they haven't followed my advice to carefully learn what a term is, they will not be able to figure out how to find the numerical value of this expression because they won't know the order in which the different operations are to be done. Okay, now, if we first ask how many terms are in this expression, all of the confusion will go away. How many terms are in this expression? Terms are quantities separated by the plus and minus signs. We have a plus sign here and a minus sign here. Therefore, A is our first term, B times A is our second term, and B here, or negative B, is our third term. So we have 3 terms. That's going to help us find the numerical value. Because what we're going to do is we're going to find the value of the second term first, b times a. b is equal to 3, a is equal to 4. So what we have here is a plus b times a, which is 12, minus b. And now everything is simple, okay? Knowing what a term is showed us how these operations are to be performed. We didn't need to memorize any special rules or any fancy songs to help us know what to do first and second and so on. We simply needed to know what a term is and then see that there are 3 terms in this expression. We then found the value of this second term first. And now we have a simpler trinomial, a plus 12 minus b. A, we said, is equal to 4. 4 plus 12 minus b, which is 3. 4 plus 12 is 16, minus 3 gives us a value of 13. So given these numerical values, this expression, a plus b times a minus b, is equal to 13. That's our answer for number 8. We're going to do one more, number 9, and then I'm going to erase the board here, and we'll do the last 4 one at a time since they're a little more complicated, and we'll just focus on each of them one by one. So number 9, we have parentheses again, which show us that although we have all of these things written, we just have 2 terms. A plus b is the first term, a minus b is the second term. So let's find the numerical value of a plus b. 4 plus 3 gives us 7, and I'll keep it in parentheses, times a minus b. A minus b, 4 minus 3, is equal to 1. 7 times 1 equals 7. So, given these values, the expression a plus b times a minus b is 7. And that's the value of the expression in number 9. Okay? Now, you can go back and watch this video again to review any of these exercises. If anything was confusing or you need to watch it over again, I'm going to go ahead and move on, erase what we've written here, and move on to exercises 10 through 13. Okay? So I'm just going to get rid of what's written here. I'm going to leave those same values at the top of the board. Okay? So, number 9, or number 10, I'm sorry. Number 10, we have x squared minus 3 times a plus x times a minus x plus 2by. X squared minus 3 times a plus x times a minus x plus 2by. If we look at this expression and think of our knowledge of the definition of terms, we'll see that we have a plus sign here, a minus sign here, and a plus sign here. So we have 3 terms. X squared is term number 1. 3 times a plus x times a minus x is our second term. And then 2by will be our third term. So let's go ahead and find the numerical value of this expression. We have x squared minus 3 times a plus x in parentheses. So let's find the value of this term in parentheses. A plus x, 4 plus 2. So we have x squared minus 3 times 6 times a minus x, 4 minus 2, which is 2, plus 2by. That gives us x squared minus 3 times 6, which is 18, times 2, which is 36. So x squared minus 36 plus 2by. X squared will be 2 times 2, which is equal to 4. 4 minus 36 plus 2 times b times y. 2 times b is equal to 3, therefore 2 times 3 is 6, times y, which is 6. That gives us 36. 2 times b times y equals 36. So we have 4 minus 36 plus 36. 4 minus 36 is negative 32. Plus 36 equals 4. So the numerical value of x squared minus 3 times a plus x times a minus x plus 2by is 4. That's the numerical value of the expression in number 10. Okay? Moving on to number 11. Again, you can back up and watch this video or parts of this video again if any of these exercises give you trouble. But I'm going to move on to try and keep this video as short as possible. Number 11. We have 2ax squared divided by, in parentheses, a minus x squared minus 6 times x times the square root of a. This is our expression in number 11. 2 times a times x squared divided by a minus x squared minus 6 times x times the square root of a. That's a reading of the expression. We can see the sign minus separates two terms in this expression. Okay? So now let's go ahead and find the numerical value. Let's start up top. 2 times a times x squared. 2 times a is 4. 2 times a equals 8. X is 2. X squared, 2 squared, is 4. So 2 times 4 is 8, times x squared is 4. That gives us 32. A minus x, 4 minus 2 equals 2. 2 squared equals 4. So the value of 2ax squared divided by a minus x squared is 32 divided by 4 minus 6 times x. X is equal to 2. Therefore, we have 6 times 2 times the square root of a. A is 4. Therefore, the square root of 4 is 2. 6 times 2 times 2. 6 times 2 is 12. Times 2 makes 24. So we have 32 over 4 minus 24. 32 divided by 4 is equal to 8. minus 24 is equal to negative 16. So the numerical value of 2 times a times x squared divided by a minus x squared minus 6 times x times the square root of a is negative 16. That's the numerical value for the expression in number 11. Again, I'm going to erase this, and the first time that you go through this, it may feel like this is moving very quickly, but you can just pause the video, back up, and watch that solution again. So I'm not rushing. I'm simply moving through the video quickly, knowing that you can go back and watch what was done as many times as you'd like. Okay, so don't feel pressured or stressed that you should be able to watch through this video one time from beginning to end and understand everything quickly. I'm moving along quickly, knowing that you can pause, back up, rewatch, and so on. Okay, so don't feel stressed. That's number 11. On to number 12. Number 12, 2 to go. Number 12, we have 3 times a plus c times a minus c plus 3a squared minus 3c squared. Let me just check that, make sure I'm right. 3 times a plus c times a minus c plus 3a squared minus 3c squared. Okay, that looks good. We can see we have a plus sign and a minus sign, so we have 3 terms. Here's our first, here's our second, here's our third. It's a trinomial. So let's work through and find the numerical value of this expression. Note that as long as this expression may be, as complicated as it may look, if you simply start with your definitions that we learned in Articles 1 through 52 and work on it one step at a time, studying term by term, you'll be able to find the numerical value simply just by using your definitions as your guide. Okay? So let's begin over here. 3 times a plus c. 3 times a plus c. 4 plus 5. A plus c is equal to 4 plus 5, which makes 9. Times a minus c. 4 minus 5, which makes negative 1. Plus 3 times a squared. A is 4. 4 squared is 16. So we have 3 times 16. Minus 3 times c squared. C is 5. 5 squared makes 25. Okay? 3 times 9 is 27. 27 times negative 1 makes negative 27. Plus 3 times 16. 3 times 16 is 48. Minus 3 times 25, which is 75. Negative 27 plus 48 minus 75 will give us the numerical value of our expression here. Now, remember in our lesson, if you look at this, it may be difficult for you off the top of your head to start with negative 27 and add 48. But remember, we learned in our lesson that we can move around the terms of an algebraic expression and it will have no effect on the value of the expression as long as the signs of each term remain the same. So let's try moving the terms around and see if it makes our solution simpler. Okay? Let's start with 48 and move 27 to the middle. And we'll leave 75, negative 75 at the end. 48 minus 27 gives us 21. And 21 minus 75 will give us the numerical value for this expression. Moving the terms around made this a little bit simpler. Okay, that's the benefit of knowing that the terms can be changed in order, and it doesn't affect the value of the expression as long as we retain the signs of each term. Okay? Now we simply have 21 minus 75, which is going to give us negative 54. Negative 54. All right, so the value of this expression here for number 12? Yes, number 12 is negative 54. Negative 54. All right? Now time for our last exercise of this first video. Number 13. And again, I'm moving quickly only because you can back up and take your time. So don't feel stressed. Number 13. A squared minus x squared over a plus x plus a minus x. Okay, this is number 13. We can see that we have three terms. A squared minus x squared divided by a plus x, that's our first term, plus a, that's our second term, minus x, our third term. So we have a trinomial. Let's find the value of this first term. A squared minus x squared. 4 squared minus 2 squared. 4 squared is 16, minus 2 squared would be 4, divided by a plus x, 4 plus 2, plus a, which is equal to 4, minus x, which is equal to 2. 16 minus 4 gives us 12. 4 plus 2 gives us 6. 12 divided by 6 is equal to 2. So we have 2 plus 4 minus 2. 2 plus 4 is 6 minus 2 equals 4. And that's our numerical value for a squared minus x squared over a plus x minus x. Now, that's all for the first 13 exercises. The rest of the exercises in Article 52 ask us to take written expressions that are written out in words and convert them into algebraic expressions. So we're going to save part 2 for a second video. I hope that's a helpful walkthrough for the exercises, the first set of exercises under Article number 52. If you run into any trouble with any of these exercises and you say watch the video, you just still can't figure it out, there's something that you're not understanding, contact me on the forums or by email and I'll try to help you figure out what's causing you trouble. All right, as I said, I'm not an algebra teacher, but this is simple. If we follow the definitions, use the terms carefully, follow the rules that were given in our lessons, we'll see that algebra is not a difficult study. It's very, very simple, much simpler than classical reasoning or classical languages. So we'll work through these studies in algebra together. I hope that's a helpful guide for this first set of exercises under Article 52. Work through these on your own. Use the video to help. Watch it as many times as you need to. And if you need any help, get in touch. God bless your studies.